Good morning. In this video, we are going to discuss the second problem in ladder. Now, let us go to the problem. A uniform ladder of length 20 meter rests against a vertical wall as shown in figure. If a man whose weight is, just note this one half that of the ladder ascends the ladder, how high will he be when the ladder slips? So here is the given system where this is the ladder which is resting on a floor where the coefficient of friction is 1 by 2 and which is resting against a wall where the coefficient of friction is 1 by 3, and if we look at this angle it is 45 degree. Now the condition is a man whose weight is half of this ladder, okay, climbs on the ladder. Okay, at some point along this on this ladder the ladder gets slipped. Okay, we have to find that distance from this bottom. Okay, the point where the ladder gets slipped. Once you understand the given problem, now the next step is you have to draw the free body diagram. Before going to draw the free body diagram, let us see how many forces are acting in this object. The first one is the weight of this ladder. Okay, it is acting at the center of gravity of this ladder. The next one is the weight of the man. Okay, so assume that this is the position of the man. The next one is, you see here there is a contact between the floor and the ladder, so there will be a normal reaction, okay, which will act in the opposite direction. Then next one is there is a contact between this vertical wall as well as this ladder, so there is also a normal reaction. Okay, more than that, at the point of slipping, you know that this end will move from left to right. Okay, so there will be a friction force opposite to that one, so this is the direction of the friction force. Similarly, this end will come down, okay, at the point of slipping, so the direction of the friction will be in this way. Okay, so these are the forces acting in the object. Now let us go and draw the free body diagram. So here is the free body diagram, and as we discussed, the forces acting in the ladders are F2. You just look at the direction, this is N2, and weight of the ladder, here the weight of the man, and here you have the friction force F, and then the last one is the normal reaction. Now WL is located at a distance of L by 2 from this end, the bottom weight, okay, where L is nothing but length of this ladder. Then this is the weight of, this is the position of the weight of the man, okay, at the time of slipping. So from this end to this end the distance is taken as x. So this is what we are going to find. We are going to solve this problem. Let us take that this ladder is a rigid body. When it is a rigid body, there are three equilibrium equations. One is summation of f of x equal to 0, another one is summation of f of y equal to 0. Then next one is summation of moment about any point equal to 0. Here I am going to consider the point B, and moreover the anti-clockwise moment is taken as positive. Now let us apply the first equilibrium equation, summation of f of x equal to 0. Now if you consider this one, there are two horizontal forces. One is N1 which is positive, another one is F2 which is negative. Now let us apply into the f of x equation. So N1 minus F2 equal to 0, and from this N1 equal to F2. So this is the first equation. Next is the second equilibrium equation, summation of all y component is 0. Again this is the free body diagram. If you see here, there are four vertical forces. One is N2 positive, WL and WM both are negative, and F1, okay, that is also positive. Now let us go to the equation, and this is the equation N2 plus F1 minus WM minus WL equal to 0. This is equation number 2. Now just substitute the basic friction equation, F1 equal to mu1 into N1 and F2 equal to mu2 into N2. Okay. Now in the place of F1 it becomes like mu1 into N1, and just to bring this WM WL to the right hand side. Now from equation 1, N1 can be replaced by F2. So in the place of N1 which is being replaced by F2. Now F2 can be written as mu2 into N2. So this equation will become like, so mu into N mu2 N2, okay. So just take this n2 outside, and now the remaining term will become like 1 plus mu1 mu2, and here WL by 2, which is nothing but the weight of the man, which is half of the weight of the ladder, plus WL. Now these two can be combined together to form a 3 by 2 into WL. Okay. Finally, if you simplify this equation, N2 will become like 3 by 2 WL divided by 1 plus mu1 into mu2. Now from equation 1, there is a relationship between N1 and N2. You see here, F2 can be replaced by mu2 into N2. Okay. So now there is a relationship between N1 and N2. So from N2, N1 can be found using the equation 1 by multiplying mu2. Okay. So this is the general equation for finding the value of N1. My advice will be just to go for this general equation. Okay. Though you know the value of mu1 and mu2, but first form the general equation. Okay. So that it can be applied into any value of mu1 and mu2. Okay. Now let us go to the next step. Now just substitute the corresponding values. For mu2 it is 1 by 2, and for mu1 it is 1 by 3. Okay, substitute the values. When you simplify the equation, you will get N1 equal to 9 by 14 W into L. Now the next equation is the summation of moment about any point is 0, but here I am going to consider the point B. Okay, moreover the anti-clockwise direction is taken as positive. So again, here is the free body diagram. Now I am going to take the moment about the point B. Okay, so this point. So these two forces are becoming 0 since there is no perpendicular distances. Now there are other 4 forces. We have to find the moment about that one. Already I discussed about this one in my previous video. Those who have not seen that video, kindly go through that one. I have given the link of that video in the description. Now first let me take the force WL. Okay. So I can transfer the force to this direction. So this is going to be my perpendicular distance. Okay, which is nothing but L by 2 cos 45 degree. The next force is the WM, and again the perpendicular distance is from this one to this one. So this is the force. So this is the perpendicular distance. Okay, this is the perpendicular distance, and you know this is a right angle triangle. Okay, so here the perpendicular distance is equal to x, okay, which is nothing but hypotenuse into cos 45 degree. Okay, moreover that is anti-clockwise direction. Similarly, WL into L by 2 cos theta is also an anti-clockwise direction. So these two moments are positive. The next one is N1. Okay, with respect to this point B, so you can transfer the N1 like this. So this is going to be the perpendicular distance. That means this is the perpendicular distance, but here it is a right angle triangle. Okay, so this distance can be found using trigonometric relationship, that is L sin 45 degree. So this one is L sin 45 degree. Then last force is the F1. Okay, but F1 can be transferred along its line of action. So this is the force F1. Now it is going to be the perpendicular distance. So for F1 the perpendicular distance is L cos 45. So this one is L cos 45 degree. Okay, but it is minus since it is a clockwise moment. Similarly, N1 is also a clockwise moment. Okay, I already discussed about these things in my previous video. Kindly look into that one. Now let us go to the equation again. So this is the moment equation, W into L by 2 cos 45, Wm into x cos 45. These two are anti-clockwise moment, so it is positive. The next one is minus F1 into L cos 45. This is clockwise moment, so it is minus. Then N1 into L cos 45 degree, which is equal to 0. This is also a clockwise moment, so it is minus. Now we know that cos 45 equal to 1 by root 2. Similarly, sin 45 is also 1 by root 2. So in the place of cos 45, you just replace this by L by root 2, and sin 45 also just replace by 1 by root 2, and substitute 1 by root 2 in all the positions. But you know that every term has a 1 by root 2 common, so it will get cancelled, and the remaining term becomes like WL by L plus WL by 2 x mu1 N1 L plus n1 into L. Okay, so in the right hand side the term n1 L is common, and in the left hand side WL by 2 is common. So I am going to take that out. Here n1 L1 is taken out. So now this is the equation. Now in the place of n1 I am going to substitute the value from the previous case, that is 9 by 14 into WL. So in the place of n1 I am going to substitute this one. Now you know that WL will get cancelled. Finally L plus X equal to 9 by 7 L into 1 by 3 plus 1. Okay, now this can be written as 4 by 3, and now this 3 and this 9 will get cancelled and you will get 3. Finally L plus X equal to 12 L by 7. So just bring this 7 into this one, okay, using cross multiplication. So now this will become like 7L plus 7x equal to 12L. Okay, just bring this 7L into this direction, this side. So it will become like 7x equal to 12L minus 7L, which is equal to 5L. Now x equal to 5L by 7, but we know that the length of the ladder is 20 meter. You just substitute here. Finally you will get the answer for x, which is equal to 14.28 meter. So finally, so this is the case, and the length of the ladder is 20 meter, but when it comes to 14 meter, this ladder will not be in equilibrium. It will get slipped. So the man can climb up to this 14 meter only. So this is what the answer for this problem. Thank you. We will meet in the next video soon.